Welcome to another Physionic video. Today we will be discussing Aerobic Detraining. Okay, back to serious. How's it going, guys? Welcome to a Physionic video. Today we will be discussing the concept of the physiology. We will go into the physiology of what happens when you and I, if I were to run a whole lot, then it would apply to me too. What happens when you stop exercising? What happens to your body? What decrements? What stays the same? What increases? What decreases? All these different things are going to be covered in a full, in-depth review of exactly what happens. Now, of course, this video is going to be quite long. That's the way things are on this channel. These videos are extremely long when it comes to the more in-depth scholarly videos. That said, there is a menu system by which you can then switch and go to different sections of the video for ease of navigation. And of course, if you don't believe anything that I said or you want more details, then I've got an article that's written below and I've got all my peer-reviewed sources in that article. So, without further ado, this video is already going to be long enough, so let's go ahead and get started, shall we? Let's do it! And the first thing that we're going to cover is the rate of detraining. So, if you cease exercise, completely cease exercise, you've been training for a year, 2 years, 3 years, however many years you've been training, and you're avidly going after it, and then you just stop exercise, and you just sit on the couch, or you just go for walks, nothing any more than that. How quickly do you see changes in your body? And the answer is variable. Yeah, sorry. Can't really tell you.
Oh, it's exactly 3% by 3 weeks, and
I can actually, but that's going to come in the next section. But as an overarching theme of how quickly overall how our body changes, that is completely variable depending on what exact physiological outcome you're looking at, and that's what we will look at now. Okay, so in this section we're going to cover we're going to break down each subsection of what makes up the physiology and what's going to end up changing or what might stay the same, or again, anything that's applicable to aerobic exercise, cardiovascular system, etc., etc. So we're going to break into each part, and you should be able to skip through the various parts if you'd like to learn about one concept more than another. Okay, that said, the first thing is VO2 max. So VO2 is just the amount of oxygen that we intake, which is of course extremely important when it comes to aerobic exercise, considering aerobic means oxygen use. So we have to have oxygen. So what happens to our VO2 max? The maximal amount of oxygen that we can take in, inspire, and exhale CO2 when we are exercising. And that seems to decrease. However, how quickly and by how much is also dependent on how long you've been training. So if you've been training for a very long time, for several years, and then you suddenly stop, then you would see closer to the higher end of this range. So the range is between 4 and 20% of your VO2 max would decrease. Now that said, how quickly does that occur? It's actually really depressing because it happens very quickly. And we are talking about within about a week to a week and a half, you'll see a sudden depression in that VO2 max. Yes, I know, it's sad. I'm crying with you. Okay, move on to the next one. The next concept we're going to cover is cardiac output. Cardiac output is basically just heart rate versus stroke volume, or time stroke volume. So heart rate being the number of hearts or beats per minute, hearts per minute. That doesn't even make sense. And the next one is, of course, stroke volume, which is the amount of blood that's released per beat. So if we look at that, then we can see that there's a decrease in our cardiac output, which is probably one of the main reasons why we see a decrease in our VO2 max. If our VO2 max is our measure, our overarching measure, then cardiac output would play into that. And we see about a 9% drop in our cardiac output. The reason being is because we see a almost immediate decrease in our plasma volume as well as our red blood cell count. And what I mean by immediate is within like the first few days up until about a week and a half. So anywhere within that range, you immediately start seeing that decrease in the volume and the red blood cell count. And if you've got less red blood cells and you've got less plasma, then you've got a lowered stroke volume, which means then again you're getting less blood through the system, through the circulation, and you're getting less oxygen, less nutrients throughout the entire system, which of course that is going to contribute to a lowered VO2 max or a performance increase or performance in general. Okay, and the next one is enzymatic activity. Yes, our enzymes are extremely important when it comes to the kinetic function, the speed of reaction. So the more of an enzyme that you have, or the quicker that it works, the more efficient that it works, well, then the better the entire system works. And if you apply that to every single cell in your body, especially those muscle cells, which are extremely important when it comes to your performance, well, you want to have that better efficiency, that better amount of these enzymes. Now, I'm just going to mention two enzymes, succinate dehydrogenase and citrate synthase, and those two are extremely important in the citric acid cycle, as well as really the entire aerobic metabolism. Now, those are the two that were measured. However, I'm sure that there are other enzymes, of course, that also downregulate due to stopping exercise, so detraining process. That said, however, we see a massive decrease in these enzymes. As a matter of fact, we see a decrease of almost 40% in this enzymatic activity, but it does occur over a period of time. It happens over several weeks that we see this slow decrease in this enzymatic activity. If you're not creating any stimulus, then those enzymes, which are proteins, aren't really being used. The body just has no use for them, so it ends up going through a process called proteolysis and then degrades them to be reused for something else. So enzymatic activity. Alright, so the next thing is muscle and capillarization. Muscle and capillarization. Okay, muscle, you know what muscle is. I'm not even going to go into that. Capillarization, though, is capillary density. So that's the amount of exchange. Those are the exchange sites. So if you think of like your veins, right? Your veins are running through your arms, running through your entire body, your arteries as well. And they get smaller and smaller and smaller until they reach the site of the muscle. That's one of the areas that they would go. So at the site of the muscle, they have to have a place where they can diffuse, where they can share those nutrients that they were carrying throughout the body and the oxygen that they were carrying throughout the body with the muscle, and that's the capillarization site. So we see an increase when we exercise, aerobically exercise, we see an increase in that capillarization, which makes sense. However, when we stop exercise, the muscle itself seems, at least after over 3 months, sees no real decrease. So the muscle itself, the capillarization does seem to decrease some. However, interestingly, after 12 weeks, after about 3 months of no exercise at all, we see that capillarization is still 50% higher. 50% higher than for a person who has never trained or is completely sedentary. So you still see that benefit even after those 3 months, which is pretty phenomenal. That's really pretty high. Next, myoglobin. No change. All right, let's move on. The next one I wanted to cover is cardiac hypertrophy. So the size of our heart. The size of our heart actually increases substantially when we go through long bouts of aerobic exercise and consistently go over these bouts of aerobic exercise. The reason why, of course, is that if you've got an increase in that blood volume, which we saw decrease earlier when we talked about cardiac output, but if you start exercising, you see an increase in that blood volume, which means that your heart muscles have to contract more to push that blood volume back out of your heart and throughout the entire system. So you can imagine that if we don't have that stimulus, if we have a decrease in that blood volume, what's going to happen to your heart muscle? Well, it's going to atrophy just like any other muscle would. So that, especially that left ventricle, which is that powerful muscle that pushes blood back out into the system, that's going to decrease. So over about 2 to 3 weeks, we see a decrease of about 20, maybe 25% of your left ventricle size seems to decrease, which makes sense. It happens with all muscle over time. It could be certainly a little bit longer for certain people, or it could be certainly a little bit less. There's a little bit of a discrepancy on, or a little bit of a debate in the literature in terms of does it really occur, but most of the literature seems to say yes, seems to indicate that yes, it does occur. And the final one, the last one, we've already covered a whole lot, but the last one is insulin sensitivity. So if you're familiar with exercise physiology, you know that aerobic exercise increases our insulin sensitivity, which is a good thing. That means that we need less insulin to shuttle more glucose into the cells, which means that we are less likely to be hyperglycemic, which means we are less likely to be diabetic. Fantastic. Love it. However, when we detrain, those benefits decrease real quick. So we see a almost immediate, within a few days, we see an immediate decrease in our insulin sensitivity of 17 to 33% decrease in insulin sensitivity. That is huge. That's a massive decrease within that, even that first few 5 to 7 days. And the reason being, or at least the predominant thought process behind that, is because we see a decrease in GLUT4. So GLUT4 is a little protein, a transporter that attaches to the cell and allows more glucose to go into the cell, and it is mediated by exercise. Now that said, again, if you're not exercising, does the body need that much GLUT4? No, it doesn't. So cuts it out, cuts out a majority of it, or a good portion of it. So, and that's the predominant theory as to why we see a decrease in that insulin sensitivity. Okay, and that is that. That's the last one that I covered. Of course, everything that I've mentioned so far has been mentioned in the article with more details, and again, I encourage you to check out my sources. Okay, now to the summary section.
This is the summary of the video for those of you that need a quick recap. If not, please subscribe and check out the attached article.
Alrighty folks, welcome to the summary section. If you did not want to go through the lengthy part of the video, I will try and summarize everything for you in a shorter style. So, what did we go over? We went over the different changes that occur within the body when you completely cease aerobic exercise. That said, what changes did we see? Well, these changes are certainly variable and they depend on the amount of time and the severity, but one of the major changes is a change in VO2 max. The more highly trained you are, the more of a decrease you see in your VO2 max of up to about 20%. That's a huge decrease in your VO2 max. Another thing is a decrease in your cardiac output, so the amount of blood that's released from your heart per minute, so that balance between heart rate and stroke volume seems to decrease due to a decrease in blood volume and red blood cells, as well as a decrease in enzymatic activity. We saw a decrease over 8 weeks, so a longer period of time. The other two were very quick, within a week, maybe even a week and a half at the very most, but enzymatic activity seems to be kind of a gradual decline. So that said, those enzymatic activities from succinate dehydrogenase and citrate synthase, which are aerobic metabolism enzymes. Those aren't the only ones that could decrease. Those are just the two that were measured. Certainly more can decrease, and it would be a shock if there weren't more that decrease. Now, another thing is a decrease in cardiac hypertrophy. So the heart seems to increase when we aerobically exercise for a long period of time in its size, its musculature, its strength, its overall just its good. And then when we detrain, we see a decrease in that muscle size, because again, if we see a decrease in that blood volume, then we're going to have less resistance, which means that we need less of that muscle hypertrophy. So we see muscle atrophy, the decrease in that size of the musculature. And another thing is insulin sensitivity. We see a decrease, an almost immediate decrease within the first few days. We see a decrease in that insulin sensitivity, which is not a good thing. However, there are other things that also didn't change. Myoglobin did not change. Muscle fibers didn't change over, I think it was about 3 months. And capillarization of that musculature, so the site of exchange where oxygen and nutrients get exchanged with the musculature, those did decrease. However, it still remained 50% higher in detrained, so previously trained individuals compared to untrained, completely untrained, had never trained seriously. So a 50% increase over those completely untrained individuals. So you still see some benefits still sticking around. However, in most cases, we see a decrease, and rather substantial and rather quick decrease in our ability, in our physiology to continue with our aerobic changes. So that is the video. Hopefully it was informative. I certainly hope that it was. This is one of my longer videos. It is one of my scholarly videos, and of course I've got an entire dedicated article to this video with my peer-reviewed sources that you can review yourself. I certainly encourage you to think outside the box. Think outside of what just my interpretation of the research, and I certainly would appreciate if you subscribed, liked, and shared to this channel. I do put a ton of work into this stuff, and I will see you in the next video. I hope that you have an awesome day, and yeah, have an awesome one. See ya.